Kummersdorf Proving Ground, Germany. March 12th, 1945. In a cold, dimly lit testing facility 40 kilometers south of Berlin, Oberingenieur Klaus Hartmann stood motionless, staring at something that would haunt him for the rest of his life. It wasn't a weapon. It wasn't a secret. It was a number. Written in his careful engineer's script, in his leather-bound notebook, the calculation stared back at him with mathematical certainty. 8.5 inches of armor penetration at 1,000 yards. The figure came from a captured American tank gun, the 90mm T-15E1, mounted in what the Americans were calling the Super Pershing. And Klaus Hartmann, one of Germany's most experienced tank weapon evaluators, understood immediately what this number meant. Germany hadn't just lost the arms race. Germany had never been in the race to begin with. This is the story of how a small team of German engineers examined American armor technology in the final months of the war and discovered that the industrial might they'd been told didn't exist was not only real, it was so overwhelming that every German tank, every tactical doctrine, and every strategic calculation had been built on a foundation of lies. And the most devastating part wasn't what the Americans had built. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. It was how easily they'd built it. Hartmann was not a Nazi true believer. He was a pragmatist, a man who had worked for Krupp before the war, designing components for civilian machinery. When war came, his engineering expertise made him valuable to the Reich, and he found himself assigned to the Weapons Testing Command at Kummersdorf, Germany's premier proving ground. His job was simple: examine captured enemy equipment, identify its strengths and weaknesses, and provide technical recommendations to the Wehrmacht High Command. By March of 1945, Hartmann had examined dozens of Soviet tanks, British vehicles, and earlier American designs. He understood their engineering, philosophy, their manufacturing capabilities, their material science. The Soviets built crude but effective machines, prioritizing simplicity and mass production. The British built solid, conservative designs that emphasized reliability over innovation. The Americans, until recently, had built the M4 Sherman, a tank that German intelligence had dismissed as adequate but unremarkable. Then, in early March 1945, something changed. A report crossed Hartmann's desk from intelligence sources in the West. American forces had deployed a new heavy tank, designated the M26 Pershing. Multiple variants existed, including one mounting a significantly upgraded gun system. Several Pershings had been knocked out or captured in recent fighting, and one, a standard M26, had been shipped to Kummersdorf for evaluation. Additionally, technical intelligence had recovered documentation and components from a destroyed Super Pershing near the Weser River. Hartmann was ordered to conduct complete technical assessment. Standing in the testing bay that March morning, looking at the intact M26 Pershing, he felt the same methodical curiosity he'd felt examining every other enemy vehicle. The tank was impressive in size, approximately 41 tons, with thick frontal armor and a turret-mounted 90mm gun. But impressive wasn't the same as revolutionary. The Germans had the Panzer and the Tiger. Surely this American tank, built by a nation with no historical tradition of armored warfare, couldn't match German engineering excellence. Hartmann began his examination with the armor. The Pershing's frontal glacis was 101.6mm thick, sloped at 46 degrees. The turret front was also 101.6mm. By German standards, this was respectable but not exceptional. The Panther's frontal armor was 80mm thick at 55 degrees, providing equivalent protection. The Tiger's frontal armor was flatter but significantly thicker. But as Hartmann examined the armor plates more closely, something unexpected emerged. The steel quality was exceptional. Using a portable hardness tester, he measured the Brinell hardness across multiple points on the hull. The readings were remarkably consistent, indicating uniform heat treatment and high-quality alloy composition. German armour production, by early 1945, was plagued by inconsistencies. Shortages of manganese, chromium and nickel meant that armour quality varied significantly from factory to factory, sometimes from plate to plate. The Pershing showed no such problems. Every plate, every weld, every structural component exhibited the kind of quality control that suggested a manufacturing process operating at peacetime standards. Hartmann made a note in his logbook: armour metallurgy superior to current German production, no evidence of material shortages or manufacturing expedients. He moved to the suspension system. The Pershing used a torsion bar suspension, similar to what the Germans employed on their own tanks. This was good engineering, providing excellent cross-country mobility. But what caught Hartmann's attention was the execution. Each torsion bar was precisely machined, properly heat-treated, showing no signs of the metallurgical compromises that increasingly plagued German production. The road wheels were robust, the track links well designed. Everything spoke to a manufacturing infrastructure operating at full capacity. Then Hartmann reached the engine compartment, and his methodical examination began to shift into something darker, something closer to dread. The Pershing was powered by a Ford GAF engine, an 8-cylinder gasoline power plant producing approximately 500 horsepower. On paper, this seemed inadequate. The tank weighed over 41 tons, giving it a power-to-weight ratio of roughly 12 horsepower per ton. The German Panzer, by comparison, had a power-to-weight ratio of 15 horsepower per ton. But as Hartmann examined the engine itself, he realized he was looking at something more significant than raw specifications. The Ford GAF was essentially a modified version of the Ford GAA engine used in earlier Shermans. It was an adaptation of existing automotive technology, mass-produced using tooling and techniques developed in America's peacetime automobile industry. The engine wasn't sophisticated by German standards. It was something far more dangerous. It was standardized. Hartmann had his team pull maintenance documentation captured with the tank. What he read made his stomach tighten. The Ford GAF engine could be removed and replaced as a complete unit in approximately 8 hours using standard field equipment. A trained maintenance crew could perform the operation without specialized tools or depot-level facilities. Replacement engines were apparently available in sufficient quantities that field commanders didn't hesitate to swap out power plants rather than attempt time-consuming repairs. For comparison, removing and replacing a Maybach engine from a Panther required multiple days and specialized lifting equipment. The engine had to be partially disassembled before removal. Replacement engines were scarce, often requiring tanks to be sent back to depot facilities in Germany, if such facilities still existed. Hartmann requested production data from intelligence sources. The numbers that came back were stunning. Ford was producing the GAA and GAF engines at a combined rate of over 1,500 units per month. A single American automotive company was manufacturing more tank engines than Germany's entire war industry, and Ford was just one contractor. Other American companies, Chrysler, General Motors, Continental, were producing additional engines for other tank and vehicle programs. The disparity wasn't just in numbers. It was in the entire philosophy of production. American engines were designed for mass production and field replaceability. German engines were designed for performance and theoretical superiority, with manufacturing and maintenance treated as secondary concerns. As Hartmann compiled his initial findings on the standard M26 Pershing, a separate report arrived from the intelligence evaluation team. They had recovered components and technical documentation from a destroyed American tank designated T-26E4, referred to by Allied troops as the Super Pershing. This variant mounted a significantly upgraded gun, the 90mm T-15E1, which was substantially longer and more powerful than the standard M3 gun. The intelligence team had recovered the gun's breech mechanism, portions of the barrel, and most critically, several rounds of ammunition, including the T-44 HVAP, high-velocity armor-piercing rounds. They had also recovered American ordnance documentation that included penetration tables for the new gun system. Hartmann was ordered to analyze the captured components and assess the weapon's capabilities. When the recovered gun components arrived at Kummersdorf's ballistics laboratory, Hartmann spent 2 days conducting a detailed examination. The T-15E1 gun was 73 calibers long, nearly 21 feet, compared to the 50 caliber length of the standard M3. The barrel was precision machined, the rifling perfect, the bore showing no signs of the erosion problems that plagued German gun production using substandard steel. The breech mechanism was robust and well designed. The recovered ammunition was revealing. The T-44 HVAP round was a tungsten core projectile, a sub-caliber penetrator designed for maximum armor penetration. Germany used similar technology in their Panzer Granit 40 APCR rounds, but tungsten was desperately scarce in the Reich. The fact that the Americans were producing HVAP rounds in sufficient quantities to issue them to individual tank crews suggested access to tungsten resources that Germany could only dream about. Using the recovered American penetration tables and his own calculations based on the projectile design and estimated muzzle velocity, Hartmann arrived at a figure that seemed almost impossible. The T-15E1, firing T-44 HVAP ammunition, could penetrate approximately 300 mm of vertical armor at 1,000 yards. Even firing standard armor-piercing rounds, the penetration exceeded 200 mm at the same range. For context, the frontal armor of a Tiger II, Germany's most heavily armored tank, was 180 mm thick on the turret face and 150 mm on the glacis. The Super Pershing's gun could defeat both from well beyond effective combat range. Even more concerning, the T-15E1 with its T-41 APC-BC ammunition could penetrate 8.5 inches, approximately 220 mm, of armor sloped at 30 degrees from vertical at 1,000 yards. This meant that any German tank, from any angle, was vulnerable to this weapon at distances where German guns struggled to penetrate American armor. Hartmann sat in his office, staring at the calculations. He ran the numbers again, thinking he must have made an error. But the mathematics didn't lie. The Americans had developed and fielded a tank gun that could defeat any German armor at combat ranges while mounted in a tank with armor thick enough to resist most German anti-tank weapons except at close range. And this wasn't a prototype. This was a production vehicle, one of multiple variants being manufactured and deployed. He pulled out intelligence estimates on American tank production. The M26 Pershing program had only recently entered full production, with several hundred tanks completed by early 1945. Plans called for thousands more. The Americans were ramping up production of a heavy tank that exceeded German capabilities, while simultaneously continuing to produce thousands of M4 Shermans for general-purpose use. But it was the Super Pershing that truly disturbed Hartmann. The T-15E1 gun represented a level of weapons development that suggested the Americans weren't just catching up to German armor technology. They were surpassing it. And they were doing so with apparent ease, as if upgrading to a gun capable of defeating the Tiger II was simply a matter of engineering refinement rather than a desperate scramble to match a superior enemy. Hartmann examined the captured ammunition more closely. Each round was precisely manufactured, with tolerances that indicated factory production under controlled conditions. The brass casings were uniform. The projectiles were perfectly machined. There were no signs of the quality variation that increasingly characterized German ammunition production as skilled workers were conscripted and replaced by forced labor. One of Hartmann's assistants, Lieutenant Werner Schulz, asked the obvious question. Herr Oberingenieur, can we replicate this gun? Can we develop something similar for the Panther or King Tiger? Hartmann looked at the young officer, a man who still believed that German ingenuity could overcome any material disadvantage. Lieutenant, we could design such a gun. Our engineers understand the principles, but design isn't the problem. The problem is manufacturing capacity, material availability, and industrial infrastructure. This gun requires high-grade steel alloys we no longer have reliable access to. It requires precision machining equipment, much of which has been destroyed by Allied bombing. It requires tungsten for the HVAP ammunition, which we lack. And most importantly, it requires time. And time is the one resource we definitely don't have. Schultz persisted. But surely, if we prioritize this, if we allocate resources… Hartmann interrupted, his voice sharper than he intended. Werner, look at these components. Look at the quality. The Americans built this weapon while fighting a PRAID, global war, while supplying the Soviets and the British, while maintaining a strategic bombing campaign that requires thousands of aircraft. They're not prioritizing. They're not scraping together resources. They're operating at a level of industrial capacity that makes our entire war economy look like a village workshop. The young lieutenant fell silent. Hartmann immediately regretted his outburst. Speaking such defeatist truths was dangerous, even among fellow engineers. But the evidence was overwhelming, and Hartmann was tired of pretending otherwise. Over the following days, Hartmann conducted additional tests on the captured M26 components. He examined the transmission, a Torque-matic transmission system that was robust and designed for ease of maintenance. He evaluated the gun stabilization system, which allowed the gunner to maintain target acquisition while the tank was moving over rough terrain. He analyzed the crew ergonomics, noting that the Americans had designed their tank around the human operators, with attention to sight lines, control placement, and crew comfort that suggested they understood tanks were operated by men who needed to remain alert and effective during extended combat operations. Every system he examined told the same story. The Americans hadn't just built a better tank. They'd built a better approach to armored warfare, one that prioritized operational readiness, maintainability, and industrial scalability over theoretical performance metrics. Hartmann compiled his technical report with meticulous care. He documented every specification, every measurement, every observation. His conclusions were professionally worded but devastating in their implications. The American M26 Pershing represents a significant advancement in Allied armor capability. The upgraded T-26E4 variant, mounting the 90mm T-15E1 gun, possesses firepower superior to any German tank weapon currently in service. Armor protection is adequate against most German anti-tank weapons except at close range. More significantly, the Pershing demonstrates a level of manufacturing quality and material science that suggests American industrial capacity operating at or near peacetime standards, despite global wartime commitments. He continued, choosing his words carefully. The T-15E1 gun system, with its specialized ammunition, can defeat the frontal armor of the Tiger II at ranges exceeding 1,000 meters. Current German armor, including the Panzer and Tiger variants, is vulnerable to this weapon at all practical combat ranges. Tactical recommendations: avoid engagement with Pershing variants when possible. If engagement is unavoidable, exploit mobility advantage and attempt to engage from flanks or rear at close range. Then came the most dangerous section of his report, the strategic assessment. Hartmann knew this would be read, if it was read at all, by men who didn't want to hear uncomfortable truths. But he was an engineer, and engineers dealt in facts. Strategic assessment, the deployment of the M26 Pershing, particularly the T-26E4 Super Pershing variant, indicates American willingness and capability to field heavy armor comparable to or exceeding German designs. Intelligence estimates suggest hundreds of Pershings currently in production with thousands planned. When combined with continued Sherman production and substantial Lend-Lease support to Soviet forces, American armor production capacity exceeds Axis capabilities by an estimated factor of 10 to 1. This disparity will increase as Allied bombing continues to degrade German manufacturing infrastructure. He paused, pen hovering over the page. What he wrote next could be considered defeatism, potentially treasonous, but it was the truth. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. And truth was what his profession demanded. The material evidence suggests that American industrial mobilization has achieved a scale and sophistication that cannot be matched by Germany's current or projected capabilities. The Pershing is not an anomaly. It is representative of systematic technological and industrial superiority across multiple domains. Continued attrition warfare against numerically and materially superior forces will result in inevitable defeat. Hartmann signed the report, dated it March 18, 1945, and forwarded it through proper channels to Wehrmacht High Command. He never received an official response, but 3 days later, a staff officer from the Ordnance Department visited Kummersdorf. The officer, a colonel whose name Hartmann never learned, sat in Hartmann's cramped office and spoke bluntly. "Your report on the American tank has been noted. The assessment is technically comprehensive but strategically premature. The Führer remains confident that new weapons systems currently in development will address any temporary material disadvantages." Hartmann said nothing. The colonel continued, "I'm here to inform you that future reports should focus on tactical and technical specifics. Strategic assessments regarding overall war production capacity are outside the scope of your responsibilities and will not be included in reports forwarded to higher command. In other words, shut up and stick to engineering details. Don't mention that we're losing. Don't mention that we never had a chance." The colonel left. Hartmann sat alone in his office, looking at the copy of his report that had been returned to him with the strategic assessment section marked through in red ink. He thought about the M26 Pershing sitting in the testing bay. He thought about the T-15E1 gun components in the ballistics laboratory. He thought about the numbers, cold and unyielding, that told a story German leadership refused to hear. Klaus Hartmann was an engineer. He believed in mathematics, in physics, in the objective reality of material facts. And those facts told him that Germany had lost World War II not in March of 1945, but years earlier, probably before the war even started. Lost it the moment American factories began converting to war production. Lost it when American engineers applied their mass production expertise to military hardware. They lost it when the industrial might of a continental economy with virtually unlimited resources decided to fully mobilize for war. The Pershing wasn't a weapon. It was a message. A message written in high-grade steel and tungsten penetrators and precision-machined components. A message that said, "This is what we can build when we try, and we're not even trying that hard." In the weeks following Hartmann's report, life at Kummersdorf took on a surreal quality. The engineers continued their work, testing captured weapons, analyzing enemy equipment, writing technical reports that fewer and fewer people read. Meanwhile, the sound of Soviet artillery grew steadily louder from the east. American and British forces advanced from the west. Germany was being crushed between two industrial juggernauts, and everyone at Kummersdorf knew it, even if they couldn't say it out loud. Hartmann received additional intelligence reports about American armor operations. M26 Pershings had knocked out Panthers and Tigers in street fighting around Cologne. A Super Pershing had reportedly destroyed a Tiger II near Dessau, though the details were sketchy, and some doubted the encounter had actually involved a King Tiger. Regardless of the specific engagements, the pattern was clear. When Pershings encountered German armor, the Americans won more often than they lost, and they were winning at ranges where German tankers expected to have the advantage. But it wasn't just the Pershing that troubled Hartmann. It was everything the Pershing represented. Hartmann requested additional intelligence data, wanting to understand the full scope of American armor production. What he learned was worse than he'd imagined. America was producing the M26 Pershing as what they called a heavy tank, later to be reclassified as a medium tank. But simultaneously, they were still manufacturing thousands of M4 Shermans every month. The Sherman, which German propaganda had mocked as inferior, was being produced at rates that exceeded Germany's total tank production across all types. And the Americans were exporting thousands of Shermans to the Soviets and British, while keeping thousands more for their own use. The numbers were staggering. By early 1945, American factories had produced over 40,000 Sherman tanks. Germany's total production of Panzer IVs, Panthers and Tigers combined was approximately 30,000 tanks across the entire war. And the Sherman, for all its supposed inferiority, had a battlefield operational readiness rate above 75%. German tanks, particularly the Panthers and Tigers, rarely achieved 50% readiness due to mechanical breakdowns. Hartmann examined maintenance reports from German armoured units. The story they told was devastating. Entire Panzer divisions were immobilized, not by enemy fire, but by transmission failures, final drive breakdowns, engine problems. The Panther, hailed as Germany's best medium tank, had a catastrophic final drive failure rate. Hundreds of Panthers had been abandoned during the retreat from France and the Ardennes offensive, not because they'd been destroyed in combat, but because they'd broken down and couldn't be recovered. Meanwhile, American maintenance doctrine assumed tanks would need regular service and designed everything around ease of repair. A Sherman could have its engine replaced in hours. A transmission could be swapped in a day. Tracks were designed with replaceable individual links. The entire American approach to armoured warfare was built on the assumption that tanks were complex machines that would break, and the solution was to make fixing them as quick and easy as possible. German doctrine assumed tanks should be built to exacting standards that would prevent breakdowns, and when breakdowns occurred anyway, the solution was to send the tank back to depot facilities for extensive repairs by specialists. In theory, German tanks should have required less maintenance than American tanks. In practice, German tanks spent more time in maintenance than American tanks and took longer to repair when they did break down. It was a philosophical difference that reflected deeper realities about each nation's industrial capabilities. America could afford to build maintenance-friendly tanks because they had abundant resources, extensive supply chains, and manufacturing infrastructure that could produce replacement parts in enormous quantities. Germany had to build complex, high-performance tanks because they lacked the industrial capacity to compete on quantity and hoped to overcome numerical disadvantages with technical superiority. But technical superiority, Hartmann realized, was meaningless if your tanks couldn't reach the battlefield or broke down during combat operations. A Panther, with a 500-meter effective range advantage over a Sherman, didn't matter if the Panther's transmission failed after 100 kilometers and had to be abandoned. A Tiger II with impenetrable frontal armor was useless if it ran out of fuel during an offensive and had to be destroyed by its own crew. The Americans understood this. They'd built tanks that worked, that could be maintained in the field, that remained operational throughout extended campaigns. The Germans had built tanks that impressed, that looked formidable on paper, that validated ideological narratives about Aryan technical genius, and they were losing. Hartmann's assistant, Werner Schulz, approached him one afternoon in late March. The young man looked exhausted, his uniform dirty, his face showing the strain of too little sleep and too much reality. "Herr Oberingenieur, I've been reviewing the production data you requested. The numbers don't make sense." "What do you mean?" Hartmann asked, though he suspected he knew what Schulz had found. "The Americans? They're producing hundreds of tanks per week. Multiple types, multiple variants. Sherman, Pershing, tank destroyers, armoured personnel carriers, and they're doing this while also producing thousands of aircraft, hundreds of ships, artillery pieces, small arms, vehicles. The industrial output is impossible. No nation could sustain that level of production while fighting a two-ocean war." Hartmann looked at the younger engineer. "And yet, they're doing it. Werner, the production numbers aren't wrong. Our intelligence was wrong. We were told American industrial capacity was limited, that they were soft, that they couldn't sustain a long war. Every piece of evidence I've examined proves those assessments were fantasies. The Americans didn't just mobilize their economy for war. They transformed their peacetime industrial capacity into a war machine of a scale never before seen in human history. Schultz sat down heavily. Then we've already lost. Yes, we lost this war sometime in 1941 or 42, probably the moment Hitler declared war on America after Pearl Harbor. Everything since then has just been determining how much of Germany would be destroyed before the inevitable conclusion. Such conversations were dangerous. Speaking defeatist truths could get you shot. But by late March 1945, maintaining the fiction seemed pointless. Soviet forces were fighting in the suburbs of Berlin. American armies had crossed the Rhine. The Thousand-Year Reich was collapsing after 12 years, and everyone except the most fanatical Nazis knew it. Hartmann continued his work because he didn't know what else to do. He examined additional captured American equipment as it arrived. A Sherman Firefly, mounting a British 17-pounder gun. An M36 tank destroyer with its 90mm gun in an open-topped turret. Each vehicle told the same story. Allied armor was good enough, reliable enough, and abundant enough to overwhelm technically superior but numerically inferior German tanks. In early April, Hartmann received orders to destroy sensitive documents and prepare for evacuation. Soviet forces were approaching Kummersdorf, the proving ground, which had been Germany's primary weapons testing facility, would soon be overrun. Engineers were ordered to demolish testing equipment, destroy prototypes, and evacuate west toward American lines. Hartmann spent a long day burning documents, watching years of weapons testing data turn to ash. He thought about saving some records, technical specifications that might be valuable to whoever won, but decided against it. Let it all burn. Let the evidence of Germany's delusions turn to smoke. Before evacuating, Hartmann took one last look at the captured M26 Pershing sitting in the testing bay. In a few days, Soviet forces would capture this facility. They'd find this American tank and probably ship it back to Moscow for their own evaluation. Hartmann wondered if Soviet engineers would reach the same conclusions he had. Would they look at this tank and see the same overwhelming evidence of American industrial superiority? Or would they, like German leadership, convince themselves that ideological fervor and tactical genius could overcome material disadvantages? Hartmann and his team evacuated west in a convoy of vehicles loaded with whatever equipment they could salvage. They drove through a Germany that was coming apart. Roads clogged with refugees, towns destroyed by bombing, columns of Wehrmacht soldiers retreating in disorder. Everywhere Hartmann looked, he saw the physical evidence of industrial defeat. German cities reduced to rubble by strategic bombing. Vehicles abandoned for lack of fuel. Weapons left behind because there was no ammunition. An entire nation consumed by a war its leadership had started, with no realistic understanding of what they were up against. Hartmann's convoy reached American lines in mid-April. They surrendered without incident, grateful to be captured by the Americans rather than the Soviets. Hartmann was processed as a prisoner of war and, after initial interrogations, was transferred to a displaced persons camp. His engineering expertise made him valuable to American intelligence, and within weeks he was being interviewed by technical intelligence officers who were very interested in his work at Kummersdorf. The interviews were conducted professionally. American officers asked detailed questions about German weapons programs, tank designs, artillery systems. Hartmann answered honestly. He had no loyalty to a regime that had ignored every accurate warning and led Germany to destruction. When asked about his examination of the M26 Pershing, Hartmann provided copies of his report that he'd kept despite evacuation orders. An American intelligence officer, a major named Patterson, read through Hartmann's report with interest. "This is remarkably detailed, Herr Oberingenieur. Your assessment of the Pershing's capabilities is quite accurate. In fact, I'd say you understood the implications better than some of our own officers at the time." Hartmann shrugged. "I'm an engineer, Major. I look at evidence and draw conclusions. Your Pershing tank, particularly the Super Pershing variant, represented a significant technological achievement. But what impressed me most wasn't the tank itself. It was what the tank revealed about American industrial capacity." Patterson nodded. "And what did it reveal?" "That Germany never had any chance of winning this war. Your industrial mobilization was on a scale that our leadership either didn't understand or refused to accept. Every component I examined on the Pershing showed evidence of manufacture in a robust, well-supplied industrial base. High-quality materials, precise machining, consistent quality control. Meanwhile, German production was collapsing under resource shortages and Allied bombing. We were trying to match your industrial output with an economy that was being systematically destroyed." "So why did you keep fighting?" Patterson asked. "If you knew Germany would lose, why continue?" Hartmann considered the question. "What choice did we have, Major? Surrender individually and be shot for treason? The war was already lost, but it took time for the military reality to catch up with the industrial reality. And by the time it was obvious to everyone, millions more had died in a futile attempt to delay the inevitable." Patterson made notes in a file. "Your technical analysis will be valuable for our post-war assessments. We're conducting extensive evaluations of German weapons programs, trying to understand what worked and what didn't." Hartmann almost laughed. "I can save you time, Major. German weapons often worked well on a technical level. Our engineering was sound, sometimes brilliant, but engineering excellence doesn't win wars. Industrial capacity wins wars. Resource availability wins wars. The ability to build and field thousands of weapons that are good enough beats the ability to build dozens of weapons that are perfect. The Pershing proved that. It wasn't the best tank in the world on paper, but you built enough of them, and they worked reliably enough, and that was sufficient." In the months after the war ended, Hartmann learned the full scope of Allied, particularly American, and industrial production. The numbers were even more staggering than he'd estimated. America had produced over 300,000 aircraft during the war, over 88,000 tanks and self-propelled guns, thousands of ships, including hundreds of aircraft carriers and battleships, 2 million trucks, millions of tons of ammunition. And they'd done all of this while maintaining a civilian economy that continued to function while feeding much of the Allied world, while supplying the Soviets and British with enormous quantities of military equipment through Lend-Lease. Germany's total war production across all categories was a fraction of American output. And Germany had mobilized essentially its entire economy for war, stripping civilian production to the minimum, drafting women and forced laborers, pushing industrial capacity to breaking point. America, by comparison, had merely shifted its existing industrial capacity toward military production while maintaining significant civilian output. The disparity was so enormous that Hartmann struggled to comprehend how German leadership had ever thought victory was possible. The answer, he eventually understood, was that they'd never bothered to do the math. They'd believed in ideology, in racial superiority, in the myth of German invincibility. They'd assumed that spirit and will could overcome material disadvantages, and when confronted with evidence to the contrary, like Hartmann's own reports, they'd dismissed the evidence as defeatist pessimism. After the war, Hartmann was eventually released from prisoner status and remained in Western Germany. He found work with a manufacturing company, returning to civilian engineering. He never spoke much about his wartime experiences. When asked, he'd say he'd been an engineer at a testing facility, nothing more. But sometimes, late at night, Hartmann would think about the M26 Pershing sitting in the testing bay at Kummersdorf. He'd remember the moment when he calculated the penetration capability of the T-15E1 gun and realized what those numbers meant. 8.5 inches of armor defeated at 1,000 yards. a gun mounted in a tank that was being mass-produced while America simultaneously fought wars across 2 oceans and supported half the world with military equipment. That single number, 8.5 inches, contained within it the entire story of World War II. It was proof, mathematical and irrefutable, that Germany had fought a war against an opponent whose industrial capacity exceeded German comprehension. The Pershing was never meant to be a wonder weapon. It was simply what America could build when it decided heavy tanks were needed. And the ease with which America built it, the quality of its construction, the thoughtfulness of its design, all of it demonstrated a level of industrial sophistication that Germany, for all its vaunted engineering prowess, had never possessed. The Americans built the Pershing the same way they built everything else during the war. Efficiently, pragmatically, in enormous quantities, with attention to reliability and maintainability rather than theoretical perfection. And that approach, boring and unheroic as it might seem, won the war. Klaus Hartmann died in 1973, a retired engineer who'd spent his final decades designing components for civilian machinery. His obituary made no mention of his wartime work. His technical report on the M26 Pershing, rejected by German High Command in March 1945, was eventually recovered from American archives and published in historical journals decades later. Military historians noted its accuracy and its author's clear-eyed understanding of the strategic situation. But the report's most important contribution wasn't its technical specifications or tactical recommendations. It was its demonstration of how ideology can blind leadership to material reality. German High Command didn't want to hear that American tanks were superior or that German industrial capacity was inadequate. They wanted to believe that German genius and fighting spirit could overcome any disadvantage. So they ignored engineers like Hartmann who tried to tell them the truth, and they continued fighting a war they'd already lost until their nation was destroyed. The M26 Pershing went on to serve in the Korean War, where it proved itself against Soviet-supplied T-34 tanks. Over 2,000 Pershings were built, and variants remained in service with various nations into the 1970s. The Super Pershing, with its powerful T-15E1 gun, was produced in limited numbers, but demonstrated concepts that influenced American tank design for decades. But perhaps the Pershing's most significant impact was never on the battlefield. It was in a cold testing facility in Germany in March 1945, where a German engineer examined an enemy tank and realized that his nation had fought a war against mathematics itself, against the cold logic of industrial production, against an opponent whose material advantages were so overwhelming that no amount of tactical genius or fighting spirit could overcome them. The Pershing wasn't just a tank, it was evidence. Evidence that the modern industrial state, with its vast resources and manufacturing capacity, would defeat the ideologically driven military state every single time. Evidence that wars aren't won by the nation with the best weapons, but by the nation that can produce enough weapons that work well enough, maintain them in the field, and keep them operational throughout extended campaigns. Klaus Hartmann understood this in March 1945, when he wrote his report on the M26 Pershing and its devastating 90mm gun. He understood that the number he'd calculated, 8.5 inches of penetration at 1,000 yards, wasn't just a ballistic specification. It was a verdict, delivered in high-grade steel and tungsten carbide, that Germany had lost World War II to an industrial power that operated on a scale German leadership couldn't comprehend and refused to acknowledge until it was far too late. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.